looking a little bit more with circumference, which we talked a little bit about the day before yesterday. And we're also using the central angle stuff that we did yesterday. So this is day 2. You do have a delta mass day. That'll release in a little bit. So today we're talking about arc lengths. And yesterday we said we have these circles and we have this central angle here. And yesterday we said that the central angle measure, so the number of degrees that central angle has, corresponds to the measure of that arc that it intercepts. So if this angle x was 70 degrees, then this arc measure would also be 70 degrees. But today we want to know about the length of this arc, meaning we're not talking about how many degrees does it have. Instead, we want to know the actual length. How many inches does it take to go from here to here? So when we talk about arc length, we want to know how long it is in some length unit, like inches or centimeters or feet or meters, okay? And what we're going to do today is we're going to create a nice little comparison. And I'm going to do it this way because we're going to see it again a little bit later. We can create all kinds of math relationships when we compare a part of something to the whole thing. Okay? So what we have here is we have this length. This is a little script L here. What are you working on?
I'll log it in.
So this is a little L for length, okay, arc length. And that length L is a portion of the whole length around the circle. We have a special formula that gives us the distance all the way around the circle. What's the formula that gives us the distance? Circumference, yeah. Circumference, what is the formula for circumference? Good, 2 pi r. So what we have here is we want to compare part of the circumference to the whole circumference of the circle. So the part that we want today is this part we're going to call L. And we're going to take that part and compare it to the whole thing. The whole thing is our formula for circumference, which is 2 pi r. That gives us the distance around the circle, okay? Now, we got to create an equation here. So the other bits of information that we have is this central angle. So this central angle that intercepts our arc here, we know that it's so many x degrees. Maybe it's 70 degrees or maybe it's 100 degrees. So that's a part of the total degrees in a circle. How many total degrees in the whole circle? How many? 360, yes. So again, all we're doing is taking this little part to whole relationship, and we can do this with a bunch of different things in math. So I have part of the circumference compared to the whole circumference, and I have part of the angle measure to the whole angle measures in a circle, okay? Now the nice thing we do from here is we can go many different directions, but how would you solve something that looks like this? This lovely cross multiply, right? We're really good at that now. Okay, I'm going to do it a little different today, but cross multiplying is always an option here. But this is very nice. So this is our arc length formula we're going to use. L over 2 pi r equals x degrees out of 360 degrees. L is the arc length. The arc length is L. R represents what? R is radius. The length of the radius, okay? X is the central angle, and then, of course, 360 degrees. Now, today in notes, I'm showing you how to do it mathematically, right? So I'm going to show you all the work, but it's way easier to do on your calculator, okay? So write down all the steps for notes, but doing the delta math turns out to be like super easy. All right, when I look here, we want to find the length of each bolded arc. So you can see that here. Here's our little bold arc right there. And that's what we want to find the length of, so I'm going to call that L. And then we're running to the nearest hundredth, so again, pay attention on delta math. What is the 6 meters?
That's your circle radius. Radius.
That's your radius. Okay, so R equals 6 meters. And this 107 is our X central angle. So I'm going to set this up. We want L over 2 times pi times 6 equals, what's our angle? 107 degrees out of how many total degrees? 360. So we're creating a fractional portion of the circle. Now, I'm trying to get L all by itself. So what can I do with all of this stuff? You can cross multiply. I'm going to make it a little bit easier and say, hey, all we really need to do is multiply it to the other side. Okay? So then I'm going to have L equals 107 times 2 times pi times 6, all divided by 360. And this is not the only way to do it, but that's how I'm going to show you today. Times 2 times pi times 6 divided by 360, and we get 11.21. Yeah. The only thing that matters is that we're dividing by only one thing. Everything else is multiplied, so it works just great. Brian?
So how would you find like the percentage of circle that it takes out?
So if that's a different question, but the percentage of the circle is this. If you divide 107 divided by 360, that is the percent of the circle. The percent is just a part out of a total. That's all it is. All right. Let's look at number 4. Again, here's our length, L. What's 9.5? Radius. Good. So the radius. And does 288 help us here? No. What do we need?
72.
360 minus 288, yeah, which is 72. Very good. So 72 is the measure of the central angle that corresponds to our arc here. All right, so I've got L over 2 times pi times 9.5, and that equals 72 out of 360. All right, do you need a pencil? All right. All right, so all I need to do is take all this stuff that right now is dividing L, and I just need to multiply it to the other side. So L is 72 times 2 times pi times 9.5 over 360 times 2 times pi times 9.5 divided by 360. And we get I want 2 decimal places, please. 9394 is right. Good. All right. 11.94 feet. All right. Easy or hard? That's pretty easy, yeah? Let's look at number 5. This is more like what you'll see in Delta Math today. EB is 15 centimeters. So EB is right here. What information did they just give us? The radius, yeah, the radius is 15. And then we want to find the length of arc CD. And again, you need to be careful. It wants the length of the arc length, okay? So we're trying to, oh, shoot, that was the wrong color. Let's do green. The length of CD is right here. That's better. Okay, that's what we're trying to find. And in Delta Math today, you're going to see some questions says, what's the measure of the arc? Measure is different. Measure is degrees, okay? But here we're talking about units of length, okay? So very different thing. I need to find this length in green here. So what do I need? 180 minus, yeah, 180 minus 68. 180 minus 68 gives us the arc that corresponds, or gives us the angle that corresponds to our arc of 112 degrees. All right, what's my setup? L over times 15, good, equals 112 over 360, good. And again, all I have to do is multiply everything to the other side, which I think I'm just going to go ahead and do on my calculator, because once you set it up, is the rest of it super easy to do in your calculator? Yeah, all right. So I'm just going to go ahead and do 112 times 2 times pi times 15, and then divided by 360. And I get 29.32 centimeters. All right, any questions? All right. Let's look at number 8. All right, number 8. JH is what? Diameter is the proper word. Good. The diameter is 21 inches. So what do we need to do? Split it in half. So the radius would be 10.5. Very good. So our radius is 10.5, and we want to find the length of major arc KJG. KJG goes almost all the way around the circle. All right, I got to find that whole length in orange. What else do we need here? Okay, so I see we've got our diameter here, so we can figure out that corresponding angle. So 180 minus 85 is 95. So that's a 95 degree angle. What else do we know? Yeah, so we do have that vertical angle pair here. So 95, that means the other side is also 95. The little sliver is 26. Okay, does that little sliver help us, or?
Yes. Yeah, it does. Wait, no, it doesn't. It's 334.
How'd you get 334? So the angle degrees, our central angle is, how'd you get 334?
I had 360 minus 26.
Okay, you subtracted the little pi piece? Yeah. Okay, how else can we get our angle of 334? Add them all up. Yeah, 95 plus 85 plus 95 plus 59. So if I add up all my angles, that's the angle that corresponds to our arc length that we're looking for. All right, which means our arc length divided by 2 times pi times 10.5 equals 334 over 360 degrees. Okie dokie. We're going to multiply that to the other side. So 334, 334, I'm going to do this, divided by 360, and then times 2 times pi times 10.5. Is this going to give me a different answer, or that one's okay too? Oh, do we think this is going to work? I'm doing it a different way.
Yeah. No. Yeah, it's right.
It's right. All right, 61.21 inches. So in this case, all I did was I just put the fractional part in first, so I got a related percent or proportion.
Wait, how can we do math if we can't calculate?
All right. All right, very good. That is a very, very big circle. Okay. Let's look at number 11 and 12, and then we're done.
What are you?
All right, we have a 16-inch pendulum. What is a pendulum? It's like the thing that swings on a clock, right? Okay. So we have the center, and then this pendulum swings down, and it swings side to side in this little arc. But it is a small piece of a much larger circle. Okay, so you imagine that we have this pendulum. It could swing all the way around, but it's impaired by gravity, so it just stays low, okay? What it's doing right now, it's a 16-inch pendulum. What is that telling you? Is it telling you the diameter, or is it telling you the radius? Okay. So the radius is 16 inches. From the center out is 16 inches. And it swings through an angle of 40 degrees. All right. So we have 40 degree, it swings through an angle of 40 degrees right here. So it's swinging back and forth in this little 40-degree arc. And we want to know how far does it the tip of the pendulum travel. So we want to know the length, GTH, the length that pendulum, imagine it starts right here and just moves to the end of its swing. That's the length we're looking to find. All right, what's my setup? L over? Equals? 40 over 360 degrees. Can I just cross off the zeros? Yeah. All right, we're going to go ahead and multiply to the opposite side. So 4 times 2 times pi times 16 divided by 36. L equals 11.17 inches. Okay. Good? All right, last one here. This is the whole reason I'm doing this way, setting them up in a proportion. The nice thing is when you set things up in this proportion, L over 2 times pi times r equals x over 360 degrees. The nice thing is it allows us, maybe I need to solve for x, in which case we're going to do that. Maybe I need to solve for r. I can cross multiply and go from there. Okay, so it allows us many, many ways to solve. So number 12, a car entered a roundabout. What's a roundabout? It's that thing that's round, like a circle, that you have to drive in a circle. From Mason Avenue and traveled 280 feet. Oh, okay. So let's say I have an intersection here, and my car is approaching the intersection, but now it has to take the roundabout to get there. So my car is entering here and then travels 280 feet and then gets off on Perry Street where it needs to go. What information are they giving me when they tell me that I'm traveling 280 feet?
The diameter, all the way, or
What did you say, Presley? You didn't say it.
Oh, it's the arc.
It's the length of the arc, yeah. This is the length of the arc. It's a measurement of feet, okay? And so they traveled all the way around on that circle 280 feet. And then it says the roundabout has a diameter of 150 feet. What's that tell us? It does tell us the diameter. Yes, it does. The diameter is 150 feet. What's the radius? Split it in half, so we get 75. All right. So our radius is 75 feet. We want to actually find the angle of rotation. So this is asking us to figure out how many degrees is that car rotating around the center. So this one is a setup that's a little bit different. What are we going to put in place of O? The 280. All right, 280 over 2 times pi times my radius. What's my radius? 75 equals x is what I'm trying to figure out. How many degrees did we rotate? X degrees out of 360. on this problem, I need to get x all by itself. What do I need to get rid of? 360. So I'm going to multiply that. That's the only thing I need to get rid of. So I'm just going to push it over to the other side. So we have 280 times 360 over 2 times pi times 75. And that's going to be our x degrees of rotation. What do I need to do when I put this in my calculator?
Make sure you do the one way.
You have to put the two.
Parentheses. Parentheses. Why do I need to have the parentheses on this one?
Because it doesn't have that.
It does do exactly in order. We want to make sure that we're telling it, we want the 2 and the pi and the 75 all being divided. So we want to make sure that we do that right. Of course, you can just use your weird old fraction thing you guys learned.
What's that?
Alright, so I've put all of the denominator in parentheses so that I get 213.9 degrees. So it rotated around the center 213, almost 14 degrees. Alright, do you have questions for me?
No.
Alright, you guys have adults in math, and
Wait, I actually do have a question.
you can, it takes like 5 minutes if you're really into it.
I have a drink. I have a question. Can I have a question? Can I get a drink?
Yeah.